Some common pairs which can be distinguished by this test is 2-pentanone and 3-pentanone. 2-pentanone gives iodoform test, whereas 3-pentanone does not. Similarly, 2-pentanol and 3-pentanol can also be distinguished with the help of this test. 2-pentanol will give iodoform test, 3-pentanol will not give. Acetophenone and benzophenone can be distinguished with the help of this test. Acetophenone will give this test, whereas benzophenone will not give this test. Ethyl alcohol and methyl alcohol. Ethyl alcohol gives the iodoform test, methyl alcohol does not, because ethyl alcohol and oxidation give acetaldehyde, which will give triiodoacetaldehyde, and with NaOH it gives iodoform. Methyl alcohol will not. Ethanol and propanol can be distinguished by this test. Ethanol is IUPAC name of acetaldehyde. Ethanol will give iodoform test because this has CH3CO group, whereas propanol does not. It does not have CH3CO group. Chloroform on reacting with concentrated nitric acid gives chloropicrin. Here H positive ion of chloroform and OH negative from nitric acid react to form water, and we will get CCl3NO2, which is called chloropicrin. It is also called trichloronitromethane. Chloropicrin is used as insecticide as it is poisonous, so it is used as war gas. Chloroform on reacting with acetone in the presence of KOH gives the addition product called chloretone. Chloretone is a hypnotic, that is sleep-inducing drug. How the reaction takes place? This carbonyl group is polar in nature. Oxygen becomes negative, carbon becomes positive. Chloroform breaks down into H positive and CCl3 negative. H positive will attack this oxygen negative to form OH, and CCl3 will attack this carbon and gets attached to this. This compound is chloroform. This chloroform facilitates the reaction. It helps to take out H ion from chloroform, which attacks to this oxygen. Next, we are taking reaction of chloroform with primary amine. It may be aliphatic amine or aromatic amine. When chloroform is warmed with primary amine in presence of alcoholic KOH, an offensive smelling compound isocyanide or carbylamine is obtained. Aniline plus chloroform plus 3 KOH will give you phenyl isocyanide plus 3 KCl plus 3 water. So this phenyl isocyanide is also called phenyl carbylamine, which has offensive smelling compound by which it can be detected. This is carbylamine reaction, which is qualitative test for primary amine, both aliphatic and aromatic. Next, we are taking chloroform reacts with phenol and KOH to form salicyladehyde. This reaction is known as Reimer-Tiemann reaction. Phenol reacts with chloroform and 3NaOH or 3KOH. On heating, it gives salicyladehyde, which is also called 2-hydroxybenzaldehyde, plus 3NaCl plus 2 water. So Reimer-Tiemann reaction is most important. Here, the active intermediate which is formed is dichlorocarbene. Dichlorocarbene reacts orthoposition. Dichlorocarbene is CCl2 with a pair of electron, and here one hydrogen is also there. So it changes to CHCl2, which on hydrolysis gives salicyladehyde. So remember, the intermediate in this reaction is dichlorocarbene. In presence of sunlight, chloroform is oxidized in air to produce highly poisonous gas called phosgene. COCl2, carbonyl chloride, common name is phosgene. Here chloroform is reacting in the presence of sunlight to form phosgene gas plus 2HCl. As chloroform is used for anesthetic purpose, it was used for anesthetic purpose earlier. Nowadays it has not to be used because of this phosgene gas, which is poisonous. But to maintain high purity, this reaction can be avoided by storing the chloroform in dark bottles completely filled up to the brim, so that air is not present and is not able to oxidize chloroform to phosgene. The use of dark colored bottles cuts the ultraviolet light which converts chloroform to phosgene gas. Another way is we can add 1% ethyl alcohol which reacts with phosgene gas to form diethyl carbonate. Phosgene gas is reacting with 2 moles of alcohol and forms diethyl carbonate, which is non-toxic and non-volatile. So we have converted a poisonous gas into harmless substance. Next we have trichloromethane. Use of trichloromethane. Chemically, chloroform is employed as a solvent for fats, alkaloids, iodine and other substances. The major use of chloroform today is production of freon, which is refrigerant named as R22. Chronic chloroform exposure means long chloroform exposure may cause damage to the liver where chloroform is metabolized to phosgene and to the kidneys, and some people develop sores when the skin is immersed in chloroform. Next we take triiodomethane or iodoform. It was used earlier as an antiseptic, but the antiseptic properties are due to liberation of free iodine and not due to the iodoform itself. Due to its objectionable smell, it has been replaced by other formulation containing iodine. Tetrachloromethane, the carbon tetrachloride, it is produced in large quantity for use in manufacture of refrigerants and propellants for aerosol means. It is also used as feedstock in the synthesis of chlorofluorocarbons, which are also responsible for depletion of ozone layers, but they are used as refrigerants in air conditioners and refrigerators and other chemicals for drug preparation and general solvent used. Until the mid 1960s, it was widely used as cleaning fluid both in industry and degrazing agent and in home as a spot remover and as a fire extinguisher. But nowadays it has been banned because there is some evidence that exposure to carbon tetrachloride causes liver cancer in humans. The most common effects are dizziness, lightheadedness, nausea, and vomiting, which can cause permanent damage to the nerve cell. And it has also found to give phosgene gas, and that is why it has been banned. Freons. The chlorofluoro compounds of methane and ethane are collectively called freons. They are extremely stable, unreactive, non-toxic, non-corrosive, and easily liquefiable gases. Freon 12 CCl2F2 is one of the most common freons in industrial use as refrigerant as well as air conditioners. It is manufactured from tetrachloromethane by Schwartz reaction. These are usually produced from aerosol for aerosol propellants, refrigeration, and air conditioning purposes. Next, we are taking para-para-dichloro-diphenyl trichloroethane, which is popularly called DDT. The structural formula of DDT is that this carbon is attached to chlorophenyl. This is chlorophenyl. Here, this carbon is attached to 3 chlorine atom. This compound is called DDT. Let's take more about halogen derivatives. How DDT is produced when chloral trichloroacetaldehyde is heated with chlorobenzene, DDT is formed. 2 moles of chlorobenzene react with trichloroacetaldehyde. Concentrated sulfuric acid will remove water and it result in the formation of DDT. One carbon is attached to parachlorophenyl group. This carbon is also attached to another parachlorophenyl group, and we have one carbon attached to 3 chlorine atoms. So this is the DDT, how it is obtained by reaction of 2 moles of chlorobenzene with chloral. 1122 tetrachloroethane is known as Westron, and when this is passed over heated lime, we get Westrosol or trichloroethylene is formed. This is Westron. When heated with calcium oxide, we get Westrosol plus calcium chloride plus water. Westrosol is used as commercial solvent for oils, paints, varnishes, and particularly in rubber industry. Carbon tetrachloride is used as industrial solvents for oil, fats, resins, etc. It was used as fire extinguisher under the name pyrene, but it has been stopped because of formation of poisonous phosgene gas. It is also one of the good dry cleaning agents. Carbon tetrachloride is used as insecticide and used as anti-hookworm medicine. Ethyl chloride or chloroethane is used in manufacture of tetraethyl lead and silicones. It is also used as refrigerant. The use of tetraethyl lead was being done in leaded petrol, which has been stopped in these days because it creates lead pollution. Acetylene tetrachloride CHCl2 is non-inflammable solvent for oils, fats, resins, paints, varnishes, rubber industry under the name Westron. Tetrafluoroethylene, that is Teflon, is the monomer of the well-known plastic called Teflon. It is used in non-stick kitchenwares because it is inert to chemical reagents and stable up to 300 degrees centigrade. The self-lubricating properties of Teflon are exploited in the preparation of low-adhesion surfaces and light-duty bearing surfaces. Even your car surfaces are Teflon coated so that they are not get rusted. Your non-stick kitchenwares are Teflon coated. Perfluorocarbons are the hydrocarbons in which all the hydrogen are replaced by fluorine, like ethylene perfluorocarbons can be polymerized to form fluorocarbons. Chloroform used for surgical purposes is tested with the help of silver nitrate solution, and if there is phosgene gas, we get white precipitate, so it has to be avoided. On reduction of alkyl halides, they give paraffins or alkanes. Bromoethane, when reduced with hydrogen in the presence of nickel, we get ethane. 1-bromopropane, when reduction is done with zinc and HCl, we get propane. And when 2-bromopropane is reduced with lithium aluminum hydride, we get propane. For HI is a good reducing agent. It will reduce ethyl iodide to ethane and iodine. We use red phosphorus so as to remove iodine so that backward reaction may not take place. What's reaction? As we have already done, bromomethane reacts with sodium metal. Another bromomethane, that is 2 moles of bromomethane are used, 2 NaBr is removed, and we get normal butane plus 2 NaBr. Friedel-Crafts reaction, benzene reacts with CH3I or CH3Cl. In the presence of AlCl3, we get toluene plus HI. Grignard reagent we can obtain by reaction of methyl iodide with magnesium. In the presence of ether as a solvent, methyl magnesium iodide, Grignard reagent can prepare almost all classes of compounds, so it is very useful. That is why the Grignard scientist who has discovered it got Nobel Prize for the invention of this reagent.